2 miles below the surface of the Mediterranean, there are lakes. Not caves, not trenches, actual lakes with shorelines and waves, and a surface that ripples when something disturbs it. They sit on the seafloor the way a puddle sits on a road, and they are lethal. Fish that drift into one do not swim out. Anything that crosses that surface dies within minutes, and then the body does not decay. It just stays there, at the edge, pickled and preserved, sometimes for years. Marine biologists who have filmed these places have a nickname for one of them. They call it the hot tub of despair. Now, here is the part that makes this stranger than it already sounds. These lakes are not some quirk of deep ocean chemistry. They are a leftover. They are the physical remains of the day the entire Mediterranean Sea disappeared. Not shrank, not dropped. Disappeared. Stick around, because the story of how those lakes ended up on the seafloor involves the largest flood this planet has ever seen, and an argument that scientists are still having right now. Let's go back about 6 million years. Back then, the Mediterranean was not a dead end. It was a channel. Water flowed through it, in from the Atlantic and back out again, the way it does today. Then the connection closed. Africa is grinding northward into Europe. It always has been, and it still is, a couple of centimeters a year. Around 5.96 million years ago, that slow collision pinched shut the gateway at what is now the Strait of Gibraltar. And that is when the arithmetic turned against the Mediterranean. Here is the thing about this particular sea. It sits in a hot, dry part of the world. Every single year, more water evaporates off its surface than all the rivers around it deliver. The Nile, the Rhone, the Po, every river feeding into it, combined, do not keep up with the sun. Today, that does not matter at all, because the Atlantic quietly tops it up through Gibraltar, and the balance holds. Take Gibraltar away, and nothing is holding the balance. The sea began to evaporate, and nothing was refilling it. Geologists call what happened next the Messinian salinity crisis, and we only found out it happened at all because of what somebody pulled up off the seafloor. In 1970, a drilling ship called the Glomar Challenger was working its way across the Mediterranean, pulling up cores from the bottom. They were expecting mud, ordinary deep-sea sediment, the fine gray stuff that settles out of deep water over millions of years. That is what the floor of a deep sea is supposed to be made of. That is not what came up. What came up was salt, layer after layer of it. Gypsum, anhydrite, halite, which is ordinary rock salt, the same mineral that is in the grinder in your kitchen. Hundreds of meters of it, and in some basins, over a kilometre thick. And you cannot get that at the bottom of a deep, healthy sea. Those minerals form in one specific situation. They form when a body of water evaporates away, and everything that was dissolved in it gets left behind, crystallizing out as the water goes. You see it in salt flats. You see it in drying desert lakes. You do not expect to see it under 2 miles of open ocean. There was really only one explanation that fit the cause, and it was almost too big to accept at the time. The Mediterranean had dried up. So try to actually picture what that looked like, because it is genuinely hard to hold in your head. Not a shallow, muddy sea, not a big lake, a basin, an enormous canyon-floored desert sitting nearly 2 miles below the level of the world's oceans. Blazing hot, because air heats up as it sinks, and this air was sinking a very long way, crusted white with salt. And the rivers kept coming. Every river that used to flow gently into a sea now found itself pouring off a cliff. So they cut down. They carved gorges into the walls of the basins, chasing the water level down as it dropped. The Nile carved a canyon deeper than the Grand Canyon to reach the bottom. That canyon is still there, buried under Egypt, filled in with millions of years of later sediment. You can map it. Engineers ran into it when they were investigating the ground for the Aswan Dam. The Rhône cut down through what is now France. You can trace its old channel hundreds of meters below Marseille. And down at the very bottom of all this, in the deepest hollows, there was still some water. Bitter, concentrated, undrinkable brine. Puddles of it, hypersaline, scattered across the floor of a dead sea. Remember those. We are coming back to them. And this was not a brief episode, a bad century. On and off, with the gateway occasionally cracking open and slamming shut again. The Mediterranean stayed like this for something in the region of 600,000 years. 600,000 years of an empty sea. Then, roughly 5.33 million years ago, the Atlantic came back. We are not entirely sure what finally did it. The favored explanations are some combination of the crust at Gibraltar flexing downward, erosion cutting backward from the Atlantic side, and sea level on the outside creeping up. What we do know is that at some point, water started getting through. And once water starts moving through a gap, it does something dangerous. It widens the gap. Flowing water erodes the channel it flows through. A wider channel carries more water. More water erodes faster. Faster erosion widens the channel further. That is a runaway. It feeds itself. And on the other side of that channel was an empty hole, nearly 2 miles deep and about 2.5 million square kilometers across. Everything after this point is reconstruction, built out of the shape of the seafloor and the sediment left behind. But according to the leading model, published by Daniel Garcia Castellanos and colleagues, what happened next was the largest flood in the recorded history of this planet. Here is what that model says it looked like. At first, it is almost gentle. Atlantic water trickles east through a shallow, widening channel at Gibraltar. It is not a wall of water, it is a stream, then a river, cutting down into rock. The erosion has been feeding on itself, and now the channel is deep enough and wide enough that the flow is no longer limited by the gap. It is limited only by how fast the Atlantic can supply it, and the Atlantic is effectively infinite. Discharge climbs toward 100 million cubic meters per second. Try to scale that. The Amazon, the largest river on Earth, moves around 200,000 cubic meters per second. This is roughly 1,000 Amazons, through one channel, all at once. The water is falling more than 1,000 meters, from the Atlantic side down into the empty basin, not as a clean waterfall, as a colossal roaring chute of water and rock and spray, tearing down a slope, carving a channel 200 kilometers long, into the floor of the strait as it goes. That channel is still down there. It is buried, and geophysicists have mapped it, and it is one of the main reasons anyone takes this scenario seriously. Inside the Mediterranean, the water level starts climbing. At peak, the model suggests more than 10 meters a day. 10 meters a day. A landmark that was dry in the morning is 30 feet under by the next morning. The old shoreline, the salt flats, the river canyons, all of it drowning at a pace you could stand and watch. In the strongest version of this model, 90% of the water transfer happens in somewhere between a few months and 2 years. A sea that took 600,000 years to disappear comes back in less time than it takes to get a degree. And there was nobody there. No people, not yet. This is the single most violent thing to happen to this region in the last several million years. And it happened to an empty stage. Except. This is the point where you should get skeptical, because a lot of scientists are. And being honest about this is more interesting than the clean version. Here is the problem with the megaflood. For an event that enormous, the direct physical evidence is surprisingly thin. A flood of 1,000 Amazons should leave unmistakable wreckage across the entire basin. And what we actually have is a buried channel at Gibraltar, some sediment deposits, and a lot of modeling. As of 2026, there is an active argument in the literature pushing back on the whole picture. Newer estimates stretch the refill out considerably, some as far as 16 years, which is still fast, but is a very different kind of event. And some researchers question whether the single dramatic flood happened the way the model says at all, or whether the basin filled in stages, through more than one gateway, less catastrophically. So here is the honest scorecard. The sea dried out. That is not in doubt. The salt is sitting right there in the cores, kilometers of it, and salt does not lie. The sea came back, also not in doubt. Exactly how violently it came back is genuinely still being argued about, right now, in journals, by people who have spent careers on it. And I would rather tell you that than pretend it is settled. But whichever way the water came back, it left something behind. And that is the part nobody argues about. All that salt, the kilometre-thick layers that were laid down while the basin baked, did not wash away when the water returned. Salt is not that easy to get rid of. It got buried under new seafloor sediment, and it is still down there right now, underneath the Mediterranean, a fossil of the time this sea was a desert. And buried salt does something strange. Under enough pressure, salt flows. Slowly, over geological time, it behaves less like rock and more like extremely stiff toffee. It creeps. It bulges upward through the sediment above it. Geologists call this salt tectonics. And it is the same process that makes the salt domes people drill for oil around. Now add the fact that Africa is still pushing north. The same collision that closed Gibraltar in the first place is still squeezing this whole basin, and that squeezing shoves the buried salt around. In places south of Crete, on a feature called the Mediterranean Ridge, that ancient Messinian salt has been pushed close enough to the seafloor that seawater can finally reach it. And when ordinary seawater touches a 5-million-year-old salt bed, it does the obvious thing. It dissolves it. What you get back is water so loaded with salt that it stops behaving like seawater, up to 8 times saltier than the sea around it, and that makes it dramatically denser, so dense that it physically cannot mix upward into normal water. So it pools. It runs downhill into hollows on the seafloor, and it settles, and it sits there. That is your lake at the bottom of the sea. That is the shoreline, and the waves you can see when a submersible nudges the surface. It is not an illusion or a trick of the lights. It is a genuinely separate body of liquid with its own surface, because the density difference between the brine and the seawater is so extreme that the two simply refuse to blend. Remember those bitter puddles on the floor of the dry Mediterranean 5 million years ago? They are back. Same salt, different water, 3 kilometers down. And then there is the life. Because these pools are sealed off from the water above, nothing mixes in. No oxygen gets down there. They are completely anoxic, and they have been for thousands of years. That is why the bodies do not rot. Decomposition needs oxygen, and it needs scavengers, and there are neither. So a fish that blunders in gets chemically fixed and stays there, ringing the edge of the pool. But at the boundary layer, in the thin band where the brine meets the ordinary seawater, something genuinely remarkable is happening. That interface is teeming. Bacteria and archaea, packed at densities you would not expect 3 kilometers down, living entirely on chemistry instead of sunlight, feeding on ammonia and methane seeping up out of the brine. And in one of these pools, researchers pushed further and found something that changed a textbook number. The pool is called Krios, and it is not just salty. Krios is loaded with magnesium chloride, which is one of the most hostile substances to living cells that we know of. It is what chemists call cheotropic. It disorders water, and it pulls proteins apart. There is a concentration above which biology was simply not expected to function. Scientists sampled the layer inside Krios, where the magnesium chloride sits above that limit, and they recovered messenger RNA. Messenger RNA matters because it is fragile and it degrades fast. Finding it is not like finding a bone. It is evidence of cells that were actively reading their own genes, working at the moment the sample was taken. Something is making a living in a fluid that, on paper, life should not tolerate. That finding pushed out the known chemical boundary of habitability on this planet. So the next time somebody describes the Mediterranean as a nice, warm sea for holidays, you know what is actually underneath it. A buried desert. A kilometre of salt from the 600,000 years. It spent as an empty hole in the map. A drowned canyon under Egypt, deeper than the Grand Canyon, and scattered across the deepest parts of the floor, lakes of that same ancient salt, dissolved back into liquid, sitting motionless in the dark, killing whatever swims into them, and quietly hosting organisms at the outer edge of what biology permits. The sea vanished 5 million years ago. Parts of it never came back. If you enjoyed this, subscribe, because next time we are going somewhere with even less light than this, where something on the seafloor appears to be making oxygen with no sun at all, and the argument about whether that is real is getting heated. See you in the deep.